Shalini Hanna, Assistant Professor, Department of Electronics and Communication, ATME College of Engineering, Mysore. Today we will be seeing the experiment on frequency shift keying, that is one of the digital modulation technique in the laboratory. Before starting, let me introduce you to what exactly modulation is. Modulation is a basic requirement for transmitting the message signal through free space. It is a process of transmission of a low frequency audio signal using a high frequency carrier signal. There are different modulation techniques which are available, that is digital modulation and analog modulation. In digital modulation schemes, we are using digital data, that is zeros and ones, for translating it into an analog signal. Then we have an analog modulation scheme wherein the center frequency of the baseband signal generated by digital modulation is shifted up to the radio signal. So we will be concentrating on digital modulation schemes. These are the various modulation schemes which are available in analog modulation and digital modulation. In digital modulation, we have for laboratory experiments ASK, FSK, PSK for the experiment purpose. So I will be showing you the experiment on FSK, that is frequency shift keying. Frequency shift keying is the frequency of the carrier signal is varied with respect to binary signal, that is 1 and 0, wherein amplitude and phase is kept constant and frequencies are changing. This is the signal, this is the output of the FSK modulated wave what we will be getting in the laboratory. We have input, we have an input which is given, that is the data stream which will be given, and we will be giving two different frequencies. One is the higher frequency and the lower frequency. This is the FSK modulated wave which will be getting. For binary 1 we will be getting high frequency signal, and binary 0 we will be getting low frequency signal. This is the demodulated wave wherein the message signal which is given will be generated back, demodulated back. And this is the IC we will be using for FSK modulation, that is CD4051. These are the IC details. This is the FSK modulator circuit which we are using it in the lab, wherein this CD4051 acts as a demultiplexer and multiplexer, and based on the pin number 6, pin number 6 what we are giving, based on that it is acting as a multiplexer or demultiplexer. If pin number 6 is given to ground, the whole IC is used as a multiplexer. If pin number 6 is given as VCC, the IC will be used as a demodulator. Here pin number 14 and 13 is given to two carrier signals, wherein one will be given as a low frequency signal and other will be given as a high frequency signal. 16 and 17 are the VDD and VE which is given, and all these things are grounded. And here we will be giving the message signal at pin number 11. At the output, since the pin number 6 is given to ground, this IC will be acting as a multiplexer, that is 2:1 multiplexer. This 2 are the inputs, and this is the select line, and this is the output. Whenever the M of t is 1, the pin number 14 is selected as a signal, that is higher frequency signal we will be getting. When M of t is 0, lower frequency signal will be getting from pin number 13. This is how the waveforms will be generated. This is about the FSK modulator circuit. This is FSK demodulated circuit. In this we are using envelope detector, we have a filter, and we have a comparator. So using all these three we will be getting the demodulated signal. So wherein the envelope of the signal will be generated, then it will filter out the noise, then finally the comparator is used to get the demodulated signal back. These are the components used for the experiment. This is CD4051 IC which will be using as FSK modulator, and we will be using two signal generators for giving lower frequency and higher frequency signal. One signal generator is used for the message signal. Then we have two lower frequency and high frequency signal. This is the circuit which has been rigged up as shown in the, as we have discussed in the block diagram. This is the modulation part. This is the modulation part which we are doing. This part is modulation part, and we have observed the modulated output which has been got from the circuit rigged up. This is the modulation output. Here for the high bit we are getting higher frequency signal. Then for low we are getting lower frequency signal. That's about modulation. Let me show you the demodulation part. This is the circuit rigged up for demodulation part. Okay, this is the demodulator output we are getting. So demodulated signal, the modulated signal MFT has been regenerated back using the demodulated circuit. This is about FSK modulation and demodulation experiment done in the lab. Thank you.